In this video, we are going to go over how to determine the reference number and terminal point of a given angle t on the unit circle. In our first problem, we are asked to determine the reference number and terminal point for the value of t being equal to 7 pi over 4. As we see on the unit circle, going halfway around the circle gives us a value of pi, and the additional half circle would give us a value of 2 pi. 7 pi over 4, however, is only equal to pi plus an additional 3 pi over 4. We therefore only need to go about halfway around the circle to get pi, then an additional 3 pi over 4, or 3/4 of the other half circle, in order to give us the additional 3 pi over 4 necessary to attain an angle of 7 pi over 4. So here we have our angle. Here's our terminal point. The first thing we wish to determine is the reference number. The reference number is the shortest distance along the unit circle between the terminal point and the x-axis. So as we make our way from the x-axis to the terminal point, we follow the shortest possible distance. We know that it took 3 pi over 4 to go from the negative x-axis to our line, so we know we need an additional pi over 4 to reach the positive x-axis. This informs us that our reference number is pi over 4. The next thing we wish to determine is our terminal point. Now, if we remember from our unit circle, we know that this angle right here, going around 7 pi over 4, we remember that the point that exists is square root of 2 over 2 for our x-coordinate, and negative square root over 2 for our y-coordinate. The terminal point is the point on our unit circle where our angle comes into contact with the unit circle. So we know that for this particular angle, our terminal point is square root of 2 over 2, negative square root of 2 over 2. For our second problem, we've been asked to once again determine the reference number and terminal point, this time for the value of t being equal to negative 5 pi over 3. Because the value is negative, we must move clockwise around our unit circle. We first move a distance of pi, and we know that 5 pi over 3 is equal to pi plus an additional 2 pi over 3. So we need to move an additional 2 pi over 3 around our unit circle, reaching about right here. And so we have our line. Our reference number for this angle, being the shortest distance from the x-axis to our point, is going to go this way. And we know that because we went 2 pi over 3 from our negative x-axis, we need an additional pi over 3 in order to reach the entire half circle. And that tells us that our reference number for this angle is pi over 3. Additionally, if we remember from our unit circle, at an angle of pi over 3, our terminal point is going to be 1/2 square root of 3 over 2. So once again, our terminal point is 1/2 square root of 3 over 2. Moving on to our third problem, we still need to determine the reference number and terminal point. The only difference being for this problem, they no longer give us a nice clean angle to work with. We now have a whole number. We know that pi is equal to approximately 3.14. So, given that our angle is about 3, we know we need to get very close, but not quite to 180 degrees, or pi. We can then draw in our angle. We now wish to determine our reference number. We know that to go completely around the half circle would give us a reference number of pi. We, however, only went around 3, So our reference number is the difference between the two, being this short angle right here, pi minus 3. Determination of our terminal point for this angle is a little bit more tricky because we don't have a consistent value given by our unit circle. We can therefore use the knowledge that the sine of any angle on the unit circle is equal to the y-coordinate of its terminal point, and the cosine of any angle given on the unit circle is equivalent to its x-coordinate for its terminal point. So we can say cosine of the angle 3 in order to determine the x-coordinate. So our x-coordinate is equal to negative 0.99. We can use the sine of 3 in order to determine our y-coordinate, y equal to 0.14. We therefore know that the terminal point for the angle t equal to 3 is going to be negative 0.99.14. For our last problem, we once again need to determine the reference number and terminal point for the value of t being equal to negative 2.5, and we'll have to use a few tricks in order to determine our terminal point and our reference number. Because our t value is negative, we need to move clockwise around the circle. We know that approximately 1/4 of the circle is equal to pi over 2. This gives us a value of approximately 1.57. We know that if we were to complete the entire half circle moving clockwise, we would have a value of pi, or approximately 3.14. We need to move 2.5, so about 3/4 of the way into the third quadrant, moving clockwise around our circle. So we make our way past pi over 2 and about 3/4 of the way into our third quadrant. Our angle is approximately right here, negative 2.5. In order to determine our reference number, we need the shortest distance from the x-axis to our line. We can see that the shortest distance is right here. Had we gone around the entire half circle, we would have an angle of pi. We, however, only went 2.5 around the circle, so our reference number is going to be equal to pi minus 2.5 in order to give us our distance along this angle. Our next determination is the terminal point of this angle. In order to do this, we once again need to use the calculator trick where sine of any angle on the unit circle is equivalent to the y value of its terminal point for its coordinate, and cosine of the angle will give us the x-coordinate of our terminal point. We can therefore plug in cosine negative 2.5, and we determine that the x-coordinate of our terminal point is equal to negative 0.80. We can use sine of negative 2.5 and determine that the y-coordinate of our terminal point is equal to negative 0.59, or to round properly, negative 0.60. And so we have the terminal point of our circle with the angle of negative 2.5 being x negative 0.80, y negative 0.60. This concludes our video on the determination of reference numbers and terminal points of a given angle t on the unit circle.